If I look at the next question, the diagram below shows the graphs of f of x is equal to minus x squared minus x plus 6 and g of x is equal to mx plus c. A is the point -2 and 4, and that is the point of intersection of the two graphs. So if I have a point of intersection, then that means that graph 1 is equal to graph 2 at that point, because a point of intersection, equation 1 equals equation 2. So at the point A, -2 and 4, the two graphs are equal. If I just pause there real quick and I look at the equation of my parabola, how do I know that that's the equation of my parabola? Well, because it's minus x squared plus minus x plus 6. So that means that A is equal to -1 based on the equation. And that would mean that I have a sad face graph. If I look at the graph, I can see that I have a sad face graph. If I look at the g of x is equal to mx plus c, I'm not really given any information about that except for the point -2 and 4. However, if I look at the equation g of x, or the line g of x, here I have g of x, what I can notice is that the y-intercept of g of x is the same as the y-intercept of that parabola. So they share the y-intercept. The first question says determine the x-intercepts of f. So for our x-intercept, we know that y has to equal 0. So we're going to let y equal 0. For f of x, they gave us the equation of minus x squared minus x plus 6. So I'm going to replace the y with a 0 is equal to minus x squared minus x plus 6. So to solve this, I'm going to make the x squared positive. So in order to make the x squared positive, I'm going to divide everything by -1. 0 divided by -1 is 0, is equal to negative x squared divided by -1 is x squared, minus x divided by -1 is positive x, and positive 6 divided by -1 is -6. Now to factorize this, I'm going to just factorize it like a normal trinomial. I look at my third term. My third term is a -6, which means that the signs are going to be different. So one's going to be a plus and one's going to be a minus. It also means that I'm subtracting the factors of 6 to give me my middle term, which is a positive 1. What are the factors of 6? 1 and 6, and 2 and 3. Which of these factors, when subtracted, will give me a 1? That's 2 and 3. So I'm going to factorize the x squared, and that's going to give me x in both of my brackets. Then I have a 2 and a 3. How do I identify which one gets which sign? I look at my middle term. My middle term is a positive, which means the bigger number gets the middle term sign. So it'll be 3 and 2. Take everything to one side, make it equal to 0, factorize fully, make each factor equal to 0. So therefore, x equals -3, or x is equal to positive 2. Now I have two x values, -3 and positive 2. So I need to identify, I have -3 and positive 2. Those are my two x values. So I'm going to look at the graph. There's my one x-intercept. There's my other x-intercept. So B will have an x-intercept of -3. And C will have an x-intercept of 2. So the question says determine the x-intercepts of f. So it didn't say that we needed to write them as coordinates. However, I would say, therefore, B's coordinates are -3 and 0. And C's coordinates are 2 and 0. The next question says, write down the equation of the axis of symmetry of f. Now, remember, the axis of symmetry of a parabola is the x value of the turning point. So we're going to calculate the turning point. So to calculate the turning point, we have the equation in standard form, minus x squared minus x plus 6. So that means that I can calculate x being minus b over 2a. So a is equal to -1, b is equal to -1, and c is equal to 6. So b is -1, so it's minus -1 over 2 multiplied with minus 1. So minus 1 is positive 1, 2 times minus 1, we have negative a half. Therefore, the axis of symmetry equation is x is equal to minus a half. The next question says determine the range of f. Now remember, domain and range, D comes before R, so x comes before y. So the domain is a list of my x values and the range is a list of my y values. So they're asking for the range of this graph. So the range of this graph will be the y values of this graph. So if I look at the y-axis, that will be my y values. All right, so my y values or my range will actually be from the turning point of this graph going down. So the range of a graph is from the maximum value to the minimum value, or from the minimum value to the maximum value, and the domain of a graph is your maximum x value and your minimum x value. So we know that the range of this graph will be from the turning point going down. Because my parabola doesn't end, it keeps going in both directions, that means that it's going to keep going to infinity. We now need that turning point, but we have the x value of the turning point. So we can now determine the y value of that turning point by substituting x with the turning point of negative a half. So that will equal minus a half squared minus negative a half plus 6. So now I'm just determining the y coordinate of the turning point, and that gives me a value of 6 1/4. However you were to write that, as a decimal, as a improper fraction, or as a mixed number. So we know that the turning point is minus a half for the x value and 6 1/4 as a y value. So the range will be a list of my y values. So y will be an element of something, and we need to determine what that something is. So the smallest y value, do you agree that this graph keeps going towards negative infinity? So the smallest y value will be negative infinity. What will the biggest y value be? Well, the maximum y value is that y value at the turning point, which is 6 1/4. So we could either write it in interval notation with our brackets. Remember, whether it's positive infinity or negative infinity, it gets a round bracket, and the turning point will get a square bracket. We could also write it as y being less than or equal to 6 1/4, or we could have put the negative infinity and the 6 1/4 with our inequality completely. The next question says, write down the equation of g in the form g of x is equal to mx plus c. So for this straight line graph, we could actually identify that we need these coordinates. So d's coordinate we know has a 0 for x, but what is the y value of this d coordinate? We have it given in our standard form over here with this positive 6. So we know that these coordinates are 0 and 6. Which means that now we have A and we have D. So we are able to therefore calculate. So we have D being 0 and 6. And we have A being negative 2 and 4. So we're able to now calculate or determine the gradient of line AD, which is equal to the change in y over the change in x. So it will be 6 minus 4 over the change in x, which is 0 minus 2. So therefore we have a gradient of 1. But we know that the d, they actually share that y-intercept. So therefore the equation of g of x is equal to mx plus c. M is the gradient, so the gradient is 1. So it's either 1x or just x plus c. C is the y-intercept, plus 6. The next question says, determine the equation of h if h is the reflection of f about the x-axis, and then translate it 3 units to the right. leave your answer in the form h of x is equal to a into x plus p all squared plus q. So for this question, I'm going to use completing the square. I'll also link the completing the square video in the description so that you can just refresh your mind about how to complete the square. Anyway, and we do a lot more examples there. So this question consists of two parts. The first part is a reflection. The second part is a translation. Now remember, a reflection is a flip. So we can either flip about the x-axis, the y-axis, line y equals x. We can flip our graph around. Then a translation is a slide motion. So we're either sliding left and right or we're sliding up and down. Remember, a slide left or right affects the p value and a slide up and down affects the q value. Now remember what I said in the beginning of the video with p and q. Our p value is the one that changes. So our q value, if we're translating up, we add to q. If we're translating down, we subtract from q. Okay, so q value, very basic, very simple. Up, add, down, subtract, which makes sense. Now with our p value, what you need to remember is with our translation of our p value, if you were to translate to the right, so then you think, okay, my number's increasing, I'm translating to the right, that means that I would add, right? So that means, because you remember that p is the opposite sign, if I'm moving to the right, I'm actually going to subtract from p. Then if I were moving to the left, now you'd think it's getting smaller, I'm going to subtract, but you remember, wait, p, not wrong sign, different sign, which means that I'd actually add. If we're sliding up, we add to q. If we're sliding down, we subtract from q. Sliding to the right, we subtract from p. Sliding to the left, we add to p. So we have our equation, f of x is equal to minus x squared minus x plus 6. So I'm going to do these two transformations separately. So I'm going to start by reflecting and then I'll do the translation. I just think it's easier that way. Also, in order to do the translation, I'm going to complete the square so that it's also easier to just add or subtract to my p value, because I'll have a p value. Because in standard form, in the form that it is now, there's an a, a b, and a c. There's no p and q. So I want a p and a q so that I can translate as well. Remember, side note, if you forget your reflections, we have a reflection above the x-axis and above the y-axis. So if you ever forget the reflection and you're like, oh no, I don't know what happens when I reflect, don't worry, you just quickly sketch this down. So if I had, for example, point A, and point A can be any value or any set of coordinates. So for this case, I'm going to make it 2 and 3. If I were to reflect A about the x-axis, then do you agree I would be reflecting it down from where it is currently? Which means that A prime, the reflection of A, would land there. And what would the new set of coordinates be? Well, this is what I just want to point out to you, is that the x coordinate remains unchanged. So that would stay 2. But what happens to the y coordinate? The y coordinate goes from positive 3 to a negative 3. So that means that a reflection about the x-axis makes y a negative y or a positive y. It changes y's sign. If I had, for example, over here, I have point B, and B is 1.5. If I were to now reflect B about the y-axis, then that means that B prime would land somewhere over here. So that would be B prime. And what would now happen? Well, the y value would remain unchanged. So the y value would still be 0.5. But what will now happen to the x value? The x value will change its sign, and the x value will now become a negative. So that means that a reflection about the y-axis, x will change its sign. So obviously that's just shorthand. It's just like a really quick way for you to, in an exam, when you're freaking out, you just quickly jot it down. So that means that now I know that I'm going to, by starting with my reflection, I know that the y is going to change its sign. All right. So I just want to quickly just do this example in full. I know it's tedious, but this way at least maybe you can wrap your head around why the signs change the way that they change. So I'm going to change the f of x to a y. So what I'm going to do is here, I'm just going to make this a y just for ease of reference. If I reflect about the x-axis, which is what the question says, then I know that a reflection about the x-axis changes the y sign. So therefore, negative y is equal to minus x squared minus x plus 6. But I can't have a minus y. I have to have a positive y. So therefore, I'm going to divide everything by negative 1. So therefore, y will equal negative x squared divided by negative 1 is x squared plus x minus 6. So now all the signs have changed. So now I've done the reflection. Okay, so the reflection was about the x-axis and that changed the y's sign. But you can actually see that by changing the y sign, a reflection over the x-axis actually changes everything on the right-hand side of the equation. Whereas if it was a reflection about the y-axis, only the signs of the x's would change. So now I have my equation y is equal to x squared plus x minus 6. And I've done the reflection. Now I need to do the translation. And the translation is a shift of 3 units to the right. So to get a p, I'm going to complete the square so that I have it in the completed square form instead of standard form, which is what I have at the moment. So to complete the square, I like to just write kind of at the bottom. So I take my b value and I divide it by 2 and I square it. Now remember, b divided by 2 all squared is exactly the same as a half times b all squared. So depending on how you prefer to do it, you can either say b over 2 or you can say a half times b, which is the same thing. So you take the b value as it is in this equation. So we can see that the b value is 1. So that will be 1 over 2 all squared. And 1 over 2 all squared is a quarter. Now, the way we're completing the square is I don't want to add and subtract to both sides because I'm keeping the y the same. So remember, we have completing the square in 2 different ways. We have it as an equation when we're solving for x, and that way what I do to the one side I do to the other. This completing the square when I'm trying to determine a turning point or trying to determine a p-value, or if I were completing the square in an expression, I wouldn't add to both sides. What I would do is I'd add and subtract to the same side. So this quarter, I am going to add and subtract to the same side, and what's in the bracket is my factor, or my factorized version. So now I'm going to say y is equal to x squared plus x. Now I'm going to take my quarter and I'm going to add and subtract it. Remember, we need to add first, so plus a quarter minus a quarter. And then I'm going to carry down my minus 6. So y is equal to, now I've created my perfect square trinomial that I can factorize. So y is equal to x, and then I take what's in the bracket as a factor, plus a half squared. And then I'm going to say minus a quarter minus 6, and I get minus 25 over 4. So now what I have is I have created a p-value. So now I know that that p-value is what's going to change with my translation. So y is equal to x plus a half, so it stays the same, but I'm doing my translation, and my translation is moving 3 places to the right. So now you'd think right plus, no, it's p. Therefore, minus 3, those are the 3 places that it's moving to the right, minus 25 over 4. And I can simply add this a half and this negative 3. But this is going to be my final step, and they asked us to write the equation in the form h of x. So therefore, h of x is equal to x a half minus 3 is minus 5 over 2 all squared minus 25 over 4. The last question says, write down the values of x for which f of x is greater than 0. All right, so this is a similar question to the other one that we were talking about. So we want f of x being greater than 0. So y must be greater than 0. Greater than 0, so I'm going to identify where is y equal to 0. And where is y equal to 0? Y is equal to 0 on the x-axis. F of x is my parabola, so I want to know where the parabola is bigger than 0. So where is f of x greater than 0? Where is f of x bigger than 0? Where is the parabola above the x-axis? So where is it above the x-axis? Between the x-intercepts, and it goes above the x-axis over there. So that means that this parabola is above the x-axis between the values of -3 and +2. So therefore, x is between -3 and 2, all right? But it says greater than 0. It doesn't say greater than or equal to 0, which means that I put round brackets. That's the one way to write it. Alternatively, we could write it in an inequality, -3 and 2.